Figure A, B, C, D, E, F has AB 8, BC 15, and EF 5. As shown, determine the perimeter of A, B, C, D, E, F. Well, from here to here is 8, obviously, as they show. From here to here is 5. So that means from there to there, from D to C, would be 8 plus 5, which is 13. And in a very similar way, since that is 15, from A to F plus E to D would be also 15. So the perimeter would be 15 on the top, 15 on the bottom, plus 13 on the left side and 13 on the right side. So that's pretty much the perimeter calculation, and that's 56. There are three distinct real numbers, ABC, that are solutions of the equation x to the power of 3 minus 4x is 0. What is the value of the product, ABC? X to the power of 3 minus 4x is equal to 0. Factor out the x, and we get x squared minus 4 is 0. And then the x squared minus 4 factors into x minus 2, x plus 2. And therefore, x is either 0, 2, or negative 2. Those are the roots. So we can just label them ABC like that. So the product ABC would be 0 times 2 times negative 2, and that is just 0. So 0 is the answer to this question. If 3 to the power of x is equal to 3 to the power of 20 times 3 to the power of 20 times 3 to the power of 18, and so on, determine the value of x. So this guy right here, since we add them, right, so it'd be 20 plus 20 plus 18, which is 58. And then this guy, again, you add the exponents, so it'd be 19 plus 20 plus 19, which is 58. And then these 3 to the power of, again, adding 18 plus 21 plus 19 is 58 again. So this basically becomes 3 to the power of x is 3 times 3 to the power of 58. And then since this is 1, you're adding again, so it would be 3 to the power of 59. And at this point, I'm sure you can figure out what is x. X is 59. And there you go. Three boxes each contain an equal number of hockey pucks. Each puck is either black or gold. All 40 of the black pucks and exactly 1/7 of the gold pucks are contained in one of the three boxes. Determine the total number of gold hockey pucks. So let's make 3 boxes, and let's see what kind of situation we have. So we have pucks in this one, and they're either black or gold, right? And in a very similar way, it's the same kind of story with the other 3, or at least for now. Let me just read the question a little bit closer. Then they're saying all 40 of the black pucks and exactly 1/7 of the gold pucks are contained in one of the 3 boxes. So let that box be this guy right here. So that means this B is 40. And this G is 1/7 of all gold pucks. So we just put G over 7, where G represents the total number. And it contains 7. 1/7. Okay. So now, if 1/7 is in this guy right here, then the other 6/7 would be in this one and this one, right? And if all 40 are in this guy, then there'd be 0 here. So 0 and 0. And then all 3 boxes contain an equal number. Okay, so that means this has to be equal to this guy. So since 1/7 is over here, the other remaining 6/7 would be in the next 2 boxes, and it will be divided equally. So 6/7 divided by 2 would be 3/7. So 3 over 7g and 3 over 7g. Okay, so that's the setup. And then now we are told that because they're equal, that means that this is equal to this. So 40 plus g over 7 is equal to 3g over 7. So if you do this math here, we get 2g over 7. And therefore, if you figure that out, it would be 280 and then divided by 2, 140. So g would be 140. And I think that's what they wanted. So there you go. The total number of gold hockey pucks is 140. In the diagram, square PQRS has side length 25, Q is located at 0, 7, R is on the x-axis. The square is rotated clockwise about R until S lies above the x-axis on the line with equation x equal 39. What are the new coordinates of P after this rotation? All right. Now, I'm not quite sure where it's going to be, so I'm just going to assume that it's... well, first let me just see here. If I rotate it slightly, I got to make this look like a square, right? And something like this. It's not going to be drawn to scale, but I think that's a pretty decent. So let me just connect the dots here. Yeah. Okay, that's pretty decent. I mean, it's not perfect, but it's okay. So that's basically what happens when you rotate it. And it's rotated about R. So R doesn't move, but the other ones move. So this one is what we're interested in. I'll just call that P prime, and then I'll call this S prime. Okay, so what are we trying to find here? The coordinates of P prime. So P prime, what are the coordinates? Okay. All right, so let's start filling this in. Okay, so length is 25. Okay. So that helps somewhat, I guess. So to avoid making the diagram messy, I'm just going to draw here where this is S prime, this is R, and this is 25. Otherwise, the diagram is going to get very messy. Okay, so then what do we have next here? Q is at 0, 7. So that means this is 7. This is 25. And then you can use Pythagoras to figure out that this is 24 because this is a right angle. So for R, the coordinates of R would be 24, 0. Yeah. Okay, that's pretty decent. And then what else can we do here? Well, this is 39. They already gave me that. So that means that from R to here would be 39 minus 24, which is 15. So I'll put 15 there. And then using Pythagoras, I can figure out this side. It'll be 20. And you guys know how to do that, right? 15 squared plus something squared would be 25 squared. And if you solve that math, that x would be 20. It's a very basic Pythagorean theorem. Okay, so then what do I do now? All right, let me just fill this in. So this is a right angle. I'll call this theta, right? And then therefore this angle in here is 90 minus theta. Okay, and I think if I draw a sort of a parallel like that, then I'll get a similar triangles type situation. So this is a right angle, so that means this angle in here would be theta. And then this angle in here would be 90 minus theta. Yeah. So those two triangles are similar. I've got to label them, otherwise it would be hard for me to kind of explain it. So I'll just call this point A and this point B. So triangle P prime A S prime is similar to triangle S prime B R. And therefore P, the ratio of the sides would be similar. And you guys know how to do that similar triangle stuff. A S prime over RB, R S prime over P prime S prime, like that. Got it? Well, some of these we know. P prime A, let's see, what do we know actually? Let's see here. Well, this guy is just the hypotenuses of those triangles, this part, right? So I think we'll just concentrate on this part. So if we do that, we change it up a bit, P prime A over A S prime is the same as S prime B over RB. And this guy here, we know S prime B, we just figured out that was 20. and then RB is 15. So the ratio is 20 to 15. And I think that would, yeah, that would make sense. So this side is 20 and this side is 15. So then we can figure out P. So P would basically be 20 before this 39. So the x coordinate would be 19. And then the y coordinate would be, I guess, this 20 plus this 15, since you're going up. So that'd be 35. So 1935, and there you go. So a little bit of, playing around, and you're able to get it through similar triangles. Lynn is tiling her long and narrow rectangular front hall. The hall is 2 tiles wide and 13 tiles long. She is going to use exactly 11 black tiles and exactly 5 white tiles. Determine the number of distinct ways of tiling the hall so that no 2 black tiles are adjacent. So, let me just draw it. Okay, we need how many? 13? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, okay, so I overdrew. That's okay, I can just delete. Okay, so we got 13, and then there's two tiles wide, so I guess we just chop it down the middle. Yeah. Okay, so now the color is what? Black. Okay, well, I'll use blue. So, I'll use red. It doesn't really matter. So this is one way of doing it. You see how I'm alternating like that? Yeah. And that is one way that follows the rules, which is that no 2 black tiles share an edge. Got it? Now, I'm going to have to call certain things, give them some distinction. So if the black tile is on the top, I'll call it a T. If the black tile is on the bottom, I'll call it a B. Like that. Now, but I don't think we have, there's only 11 black tiles. Okay, so some of these are going to be empty. I got it. Yeah, because I think I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So some of these are going to be empty. So let me delete some of them. And therefore, if a column does not have any black tiles, I'll call it E. E for empty. So there you go. That's just one of many ways of creating this scenario. So we have to add up all the different ways. Oh boy. So I think there's going to be several ways of doing this. So let's take this one step at a time. Okay, so the first way would be if the 2 E's are at the end. So 2 E's, the 2 empties, are at the end. So that would mean, a situation where we have TB, dot, 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 and then E at the very end. That's one way. Or you could have BT, like that, and then E at the very end, the 2 E's. Or you could have the 2 E's at the front, and then have a TB type situation, TB, dot, dot, dot. Or you can have EE at the front, and then BT alternating. So these guys give you 4 scenarios, and that's one way of doing it. And I think we're going to have several more, so let's just put this in categories. Okay, so we got 1. Another way is if you have the EE somewhere in the middle, so they're not at the end anymore, but they're still together. So something like you got TB, and then you got the EE, and then you got, TB, like that kind of thing. Okay, so the EE would have 10 possible locations where you could put it. 10 locations for the EE, right? Any location except the front and the back, the end, the beginning and the end, because that's already been covered up here. And then, what would happen is you'd have two blocks on either side, and each block has two ways of being made. Let me explain. So, for example, that could also be made as BT TB. You see what I'm saying? So there's two, or you could have EE and you could have TB and BT, or you could have EE, BT and BT, like that. So there was two possible ways of doing that, and two possible ways of doing that, and 10 possible ways of doing that. So 2 times 10 times 2 would be the math, and 2 times 10 times 2, I believe, is 40. So 40 goes there, and that is another way of figuring out the scenarios. Okay, let's keep going here. The next one is a scenario where the E's now are broken up. So we have an E at the very end, and then you have a whole bunch of TBs or whatever, TB, like that. And then you can also have E's at the other end, each end, and then you have BT. So these give you another 2. So that's all there is there. And then I think I have just 2 more scenarios. Let me see what those scenarios are. Let's see here. What else would we do? The next scenario is where you have an E at one end, and then the second E is somewhere in the middle, like that. So what that creates is we have 2 possibilities for the first E that is at an end. It could be at the beginning end or the final end, meaning at the very end. And then the second E has 10 possible choices. So 10 choices for the second E, right? Because it can't be at the very end, because that would create one of these scenarios, I believe, yeah. And then we have 2 blocks. So this would be TB, 2B, and so on, right? So you have this block, and each block has 2 configurations. You can have TB, or you can have BT, right? So 2 for the first TB, or first block, I should say. It's probably better to write block. 2 choices for the first block, and 2 choices for the second block. So block number 2. And then let's multiply these all together. So 2 times 10 times 2 times 2, and that is 80. Okay. And now I think we're down to the last one, the last scenario of how to do this. So the last scenario, let's see. This is when both E's are buried inside. So you start off with, let's say, a TB, and then you got an E, and then you got TB, whatever, and then you have another E, and then you have TB, and like that. So as you can see, the 2 E's are buried inside. That would give me a scenario of the first E, the second E, and then 3 blocks this time, right? You got first block, second block, second block, and then third block. So block 1, block 2, and block 3. Now let's see what are the possible numbers for each. For the first E, let's see, we have, let's see here. The first E, well, I think we got to go case by case here. So for example, if the first E was the second spot, how many are there? 13, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If the first E is here, the second E cannot go there because we can't put them together. But we can put the second E either 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the first E is the second. Then, hold on, let me write this in a structured way. If it's like this, we have 9 locations for the second E. Yeah. And then if the first E was in the third spot, then we have 8 locations for the second E. You see what I mean? And then similarly, you just keep going down, all the way down to 1. If I think, let's see here, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, if the E was here, then we'd have only one spot for the E, for the second E. So all of these would be 9 plus 8 plus 7 plus 6, and so on, all the way down to you get to 1, and that is 45. So 45 ways to put those E's in that, whatever, in that string where they're not together and they're not at the ends. And then for each of those, you're going to have 3 blocks. You're going to have this block, you're going to have this block, and you're going to have this block. And for each block, you have 2 possible ways of making it, either TB or BT. And these ones, there was 45. So the total would be 45 times 2 times 2 times 2. And that's 360. So now I think we're done. So now we got to add it all up. So we got this 4. We have this 40. This 2. This 80. And this 360. So when you add it all up, we have, we had 4 plus 40 plus a 2 plus an 80 plus a 360. And when that is all added up, it's 486. And that is the answer to this question.